Welcome to join this Chemcare program in semester 2, session 2025-2026. Now we will go to chapter 1, reaction kinetics, stage 1. For question number 1a, for the following reaction, 4 mole of A react with 3 mole of B to produce 2 mole of C and 6 mole of D. Question A1, write the differential rate equation for the above reaction. A2, if the rate of formation of C gas is 0.72 m per second, calculate the rate of formation of D and rate of disappearance of B. So to write the differential rate equation, we must know the stoichiometry coefficient for the reactants and products. And also we need to put the negative sign for reactants and positive sign for products, because the reactants are decreasing with time while the products are increasing with time. So we have to start by writing the word rate equal to negative 1 over 4 dA over dt equals to negative 1 over 3 dB over dt equals to positive 1 over 2 dC over dt equals to positive 1 over 6 dd over dt. So 1 mark for this differential rate equation. Next, to calculate for question A2, the question gives us the rate of formation of C gas 0.72 m per second. So we need to calculate the rate of formation of D. Okay, so we need to find the relationship between C and D from the differential rate equation. So the given is the C, while what we want to find is the D. So we take this information from the differential rate equation. And then we know that the question gives us the positive dC over dt equals to 0.72 and s negative 1. So we take the relationship between C and D from the differential rate equation. So positive 1 over 6 dt over dt equals to positive 1 over 2 dC over dt. Then we insert the value of dC over dt equals to the 0.72 into the equation. Then we will get the positive d over dt equals to 3 times 0.72. So the final answer is 2.16 and s negative 1. So make sure you move the coefficient to the side that with the dc. So the marks is given for the relationship between D and C, and then the final answer with unit in C's. Okay, and then to calculate the rate of disappearance of B, again we need to take the relationship between B and C. Okay, so negative 1 over 3 dB over dt equals to positive 1 over 2 dC over dt. So now we want to find the rate of disappearance. That's why we have a negative sign in front of the dB over dt equals to 3 over 2 multiply the value 0.72. So we get the final answer 1.08 and s negative 1. So remember, the final answer should be a positive value. Only the expression of rate can be positive or negative. Depends whether it's formation or disappearance. So the marks is given for the relationship between B and C and final answer. Next we go to question number 1b. NOBr is decomposed through a second order reaction as below. 2 more NOBr produce 2 more NO and 1 more Br2. Question 1. When the reaction begins with 0.6 molar of NOBr, it took 6.25 seconds for 75% of the reactant to react. Calculate the rate constant for this reaction. 3 marks. And then number 2, determine the half-life for the reaction. 2 marks. So the question gives us the initial concentration 0.6 molar, and then the time 6.25 seconds, and 75% reactant decomposed. So we need to find the NOBr that remain, which is 25% out of 100% times the initial concentration. So we get the NOBRT equals to 0.15 molar. 1 mark for this value. and then we have to apply the integrated rate equation for the second order reaction. Okay, so the integrated rate equation is 1 over NOBRT minus 1 over NOBR naught equals to KT. We use the integrated rate equation here because it relates two different concentration at initial and at the time t, and then it can help us to find the rate constant K. Okay, so we insert the value into the formula. 1 over 0.15 m minus 1 over 0.60 m equals to K times 6.25 seconds. So 1 mark for the formula or insertion value, and the final answer K equals to 0.80, m negative 1, s negative 1, 1 mark. So the unit is in cis. Next, to calculate the half-life for this reaction, we also apply the formula half-life for the second order reaction, which is 1 over K times NOBR naught. So we insert the K value that we calculated from B1 and the initial concentration. So we get the final answer 2.083 seconds. So 1 mark for the formula or insertion value, 1 mark for the final answer. Question number 2. The reaction below was studied at negative 10 degrees Celsius. 2 more NO react with 1 more Cl2 form 2 more NOCl. By using the initial rates method and the experimental data in table 1, determine A, the rate law, B, the rate constant, and C, draw a complete labor energy profile diagram if the reaction is exothermic. So the table given including experiment 1, 2, 3 data. So to calculate the rate law, we need to determine the order for NO and Cl2. So we will start by the assumption rate equals to K times NO to the power of M times Cl2 to the power of N. So you can use any alphabet to represent the order for these two reactants. Okay, 1 mark for this assumption. Okay, then to determine the order M, we need to compare the experiment 1 and experiment 3, because experiment 1 and experiment 3, they have different value for the NO, but they have the same concentration for the Cl2. Okay, so experiment 3 over experiment 1 equals to, okay, so we insert the value of the initial rate and also the concentration for NO and Cl2. So we found that the Cl2 0.1 to the power of N can cancel out, the K cancel with K, so we will get 2.25 equals to 1.5 to the power of M. So we can put log on both sides, then we can get the M equals to 2. So this is second order respect to the NO. So you compare experiment 3 to experiment 1, get 1 mark, and then you get second order 1 mark. Okay, next we calculate the order N. So to calculate the order N, we need to compare experiment 2 and 1, because 2 they're having the same concentration of NO but different concentration of Cl2. So experiment 2 over experiment 1, 4.5 power negative 3 equals to K times 0.1 power M times 0.15 power N over the experiment 1 value. Okay, so the K can cancel each other, 0.1 power N also cancel. So at the end we get 1.5 equals to 1.5 to the power of N. So we can get N equals to 1, which is first order with respect to Cl2. Okay, so the rate law is rate equals to K times NO to the power of 2 times Cl2. So this is 1 mark. Question number 2b. To calculate the rate constant, we can take any experimental value. For example, I took the experiment 1 value. So rate equals to K times NO to the power of 2 times Cl2. So K equals to 3 power negative 3 over 0.1 to the power of 2 times 0.1. So the final answer is 3 m negative 2 s negative 1. So the unit is coming from the value, so you have to consider the power. Okay, so the m is negative 2 and the s negative 1. So 1 mark for the insertion value, 1 mark for the final answer. Then for question C, we need to draw the complete labor energy profile diagram given the reaction is exothermic. Exothermic means the delta H is negative, means the heat is released. So the product having lower energy compared to reactant. So this is the energy profile diagram. So the x-axis is the reaction progress and y-axis is enthalpy in unit kilojoule per mole. So the curve is you have to show that the product having lower enthalpy than the reactant, and then you need to label the reactants 2 more NO plus Cl2 and label the product 2 more NOCl. And don't forget to label the activated complex on the top of the curve, and then from the reactant to the activated complex is called EA, activation energy, while the difference between the reactant and product is the delta H with negative value. So the marks is given if you draw the axis and shape correctly and label reactant, product EA, delta H and activated complex, 1 mark. Question number 3a. The rate constant for the decomposition of hydrogen peroxide is 0.65 m negative 1 s negative 1 at 400 degrees Celsius. If the activation energy for this reaction is 200.8 kilojoule per mole, what is the rate constant at 200 degrees Celsius? So the question gives us the K, and also we have the T1, EA. So now we need to find the K2 with different temperature. So we apply the Arrhenius equation here. Ln K1 over K2 equals to EA over R times 1 over T2 minus 1 over T1. So we insert the K1, T1, T2 value, and we need to find out the K2. So you need to convert the temperature into Kelvin. So we use the temperature in degrees Celsius plus 273.15. And the R value is 8.314 joule per mole per Kelvin. So the activation energy also need to convert to joule per mole. So 200.8 times power 3 joule per mole. So 1 mark for the formula, 1 mark for insertion value, and final answer K2 equals to 1.68 power negative 7 m negative 1 s negative 1, 1 mark. Question 3b. Explain what happens to the rate of reaction if the reactants used at higher concentration, 3 marks. So when higher the concentration of reactants used, the number of reactant molecules per unit volume increases, and the reactant molecules are closer to each other. So the main keywords here, you have to mention that number of reactant molecules per unit volume increases, 1 mark for this. And then frequency of collision increases, frequency of effective collisions increases, and finally the rate of reaction increases. Thank you for watching this Chemcare chapter 1 stage 1.